All right, so we're trying this again because yesterday's didn't work to make sure that we get our recording right for solving some linear equations by multiplying first. So what we're going to do is just an extension from last time. We're still solving by elimination or addition, subtraction, however you want to think of it, except that there's one step ahead of it first. So that first step you're looking at is the very first thing to do, and you can see here with our elimination problem that the x's and the y's, neither of them really line up to be equal or similar to each other. So what we're going to do is we're going to change them. And how you do that is you use what's called a scalar, and you multiply an entire equation by a number. In this case, I'm going to pick 2. So the reason why I'm picking 2 is that if I pick 2 and multiply all the way through, this 3 and 6 are now going to be the same, which is really cool because then you have the same number. So we're going to basically do a distributive type property here where you're distributing through to everything. And what you get is 6x minus 6y equals 42. So now that we have this, we can go through and add or subtract like normal. And in this case, we are going to add, because we have a negative 6y and a positive 6y. So a negative plus a positive gives you that 0 that we're looking for. So we get 14x, and that cancels out, and this is going to equal 28. So we get x by itself, we're going to divide by 14, divide by 14, then x equals 2. From there, keep going like normal. We're going to plug that x back in, so let's put it in the first equation. So 3 times 2 minus 3y equals 21. And we get 6 minus 3y equals 21. We're going to subtract the 6 from both sides. So negative 3y equals 15. And then divide by the negative 3 to get y equals negative 5. So our equation is 2, negative 5. So our point is 2, negative 5. That's the coordinate. All right, so there's the first one. So nothing has really changed from elimination except for this first piece. So if you could do elimination from the day before, all you're doing is adding in this to begin with. Let's try another one. So next one we have is 3y equals negative 2x plus 17 and 3x plus 5y equals 27. Now there's actually going to be 2 steps here, because the first thing we have to do is get all the x's and y's on the same side. So we're going to add 2x and add 2x. So we get 2x plus the 3y equals 17. Now this one's even a little bit more difficult because you now have to do multiply both. You can see that you can't multiply the first one by some number to get the second one right away. So we do have to multiply each one by something. So I look for what's my smallest set of numbers. So 2 and 3 are the smallest ones. And I want to figure out what can I multiply each one by to get a common number. And in this case, I'm going to try and go for 6. So I multiply the first one by 3. So multiply this whole first one by 3. I would get 6x plus 9y equals 51. And the second one I would multiply by 2, because that gives us 6 again. So 6x plus 10y equals 54. So you got to pick wisely so you don't get stuck with some numbers that don't work. So you got to make sure you've got them that so they equal correctly out. All right, so now what we're going to do is figure out, do we add or subtract? And since our 6x and 6x are both positive, they're both the same, we are going to subtract those two from each other. So subtraction will have a negative sign out front. 6x minus 6x gives us nothing. 9y minus 10y gives us a negative 1y. And 51 minus 54 gives us a negative 3. So again, we're going to divide by negative 1. And y equals 3. Now all we're going to do is plug that back in. So we're going to plug into the top. So 3 times 3. That's this equation right here. 3 times the 3 is negative 2x plus 17. So that would mean that 9 equals negative 2x plus 17. And we're going to subtract 17 from both sides. So negative 2x equals negative 8. divide by -2. So x equals 4. So our coordinate is 4, 3. All right, next one we got x and y is already lined up, but what I want you to do is I want you to try this one on your own. So you can get it. Pause the video for a second and have a chance to go through it, and we'll get back together in about a little bit to go through. All right, you should have had a chance to go through it. We're going to look at what variable do you want to solve for, x's or y's. In this case, again, looking for your smallest one, I would pick the y's. So you have a 2 and a -5. And what number do both 2 and 5, what number do they go into? And that'd be 10. So we're trying to get 10. We're going to multiply this one by 5 to get this number, that 2y right there, to be a 10, and that by 5. And we're going to multiply this one by 2 to get this one to be 10. So if multiplied by 5, we'd have 35x plus 10y equals 130, and 20x minus 10y equals -20. So we want to make sure we get those to be 0, and 10 plus -10 gives you 0, so we're going to add. So that gives you 55x. Those two cancel out, the y equals 110. And if you divide by 55, you should get x equals 2. So we're going to just plug that back in. Let's say we plug back in the first one. So 7 times our 2 that we've got, plus 2y. Sorry about that, looks really weird. 2y equals 26. And we've got 14 over here, so 14 plus 2y equals 26. Subtract 14 from both sides. 2y equals 12. And y then equals 6. All right, so our coordinate is 2, 6. All right, again, I apologize for having this go so long and not showing up the first time. I will make sure I check those a little more thoroughly before I post them again. And have a good day.